Hello everyone, I'm Alisson from Federal University of Goiás in Brazil, and today I want to present our work, Mars Gene, a gene framework to model, train and evaluate recommended system for marketplace. This paper is joint work between Deep Learning Brazil Group and iFood Company. This presentation can be divided into three parts. In the first part, I introduce a reinforcement learning approach for recommended system and some challenges into the industry. In the second part, I explain the framework and some components. Then in the last part, I will show some experiments. Recommended systems are especially challenged for marketplace because they need to maintain such ecosystem healthiness and fairness. Traditional approaches face challenge in addressing issues such as user-centric perspective. Marketplace has a multi-site perspective, and it is essential to maintain the ecosystem healthiness. Partial observable feedback. We never know the real user preference because in general, the data that we use to fit a model has a lot of bias and no stationary problem. Everything in the marketplace changes over time. User interest in cataloging, supply information, available items to recommend, so everything stays change. It's not a stationary problem. We can formalize a recommended system as a Markov decision process and modeling using reinforcement learning approach. So in this case, the environment is the marketplace and the agent is the recommended system. So the environment sends an observation to the agent that needs to choose on action. The action for us is a recommended item, for example. And the question is, what is the best item for this user at the moment using this context, using this observation. So the action interaction with the environment and the result is a reward signal. The reward signal show how good the action was. The reward signal can be anything, can be a click view, for example, in a one objective approach, or some information that combines all marketplace stakeholders interesting in a multi-objective approach. So we can use contextual bands to train a policy P, where X is the contextual information and A is a recommendation to the user. Contextual information is access information, user information. The policy P needs to choose the best action for the context. But here we have an exploration-exploitation dilemma, because in reinforcement learning, I need to explore the environment. Reinforcement learning is about trying, error, and collect feedback to improve the current policy. So it's a cycle, step by step. The agent needs to make a decision each step to try and maximize the cumulative reward. So the objective is to maximize the expectation of cumulative reward. And there are limitations and challenges in the process and in existent work. For example, train and reinforcement approach in production is not simple because it's necessary to interact with the environment, like try, error, and collect feedback. My policy or my model needs to make mistakes, and sometimes it costs a lot. The question is, how much does the wrong decision cost for the problem? In our case, a recommendation in a food delivery maybe costs more when it is a new user, for example. Therefore, it is important to pay attention to new approach. So when you try put new approach in production. Assistant simulators are user-centric or using simulated data. Like Recoding, and Rexing. Marketplaces are a multi-site environment, and it industrial context. It is essential to maintain the simulation close to reality. So for us, use a real data set for simulation is a good thing to do. We need to test. We need to test a lot and simulate policies before we put this kind of approach in production. So we present Mars Gene, marketplace recommended system gene. a benchmark framework for modeling, training, and evaluation reinforcement learning based recommended system for marketplace. Three main components compose the framework and can be customized. I'll explain better its components. It is a margin architecture. Use real data sets. So first, the data engineer module is used to transform, filtration, and separate user-item interaction, for example, or separate metadata from user and item. You can customize everything in this module, but the main idea is putting this data in specific pathnet for the simulation module. So for us, the simulation module is the core of the margin and implements the MDP simulation. So it's also the module to design and train learning agents too. Step by step in this module, the gene environment gets a real interaction to simulate a new interaction. Every k time, the simulator uses the generated data to update the policy into the recommendation agent. Here we can customize the recommendation agent and some simulate parameters too. The recommendation agent is a contextual-based model, and we use PyTorch, a deep learning framework, for train this policy. So everything at Mars generates logs. We use these logs from simulation to evaluate the trained policy in different aspects. The evaluation module apply different metrics like rank metrics, of policy metrics, and fairness metrics. We can customize this module to append new metrics, for example. The idea is to evaluate different policies, strategies, and models, not only using accuracy metric. In general, accuracy metrics are user-centric, but also measure fairness and simulate quality too. Here it's an example of the margin command. So you have different types of parameters, but this is the basic. To run some new simulation, some new experiment, we need to define simulation settings with the full parameters of the simulation and database information. After this, the parameters of contextual bands oracle. It is a PyTorch model to estimate the reward and contextual band policy. For example, eGrid or UCB. Margin has different policies already implemented, but you can make your own policy. After the end of the simulation, you can run the evaluation module for this experiment, for example, and you can configure what metric do you want to run, for example. Here we have a diagram flow of the simulation. For example, first we have the ground truth dataset. We separate the context of the supplier or item information. The context is the user session information, metadata, for example. The agent and the environment never know the correct answer, only the contextual information. So the agent and the environment don't know the correct item, for example. The agent needs to explore using a current policy, and if the agent recommends the right item, you receive a positive reward. If not, zero reward. So this MDP creates a simulated dataset, and we use this dataset to improve the current policy step by step. And at the end of the simulation for model evaluation too. So we need to care about some issues. For example, bias. The original dataset has a correct bias. Its distribution came from another recommended system or another process. It never comes from the random distribution, for example. So margins use the counterfactual risk minimization of policy learning. The oracle or reward estimator is trainable by bets using partial feedback from the simulated data set. CRM loss is important to train unbiased estimator, reduce the bias of the original data set. This is the formula. So we consider uniform distribution over actions to account for the fact that the data come from the production policy, like PC is a different policy, and not from a uniform random experiment, for example. Margins implement three groups of metrics to ensure the simulation quality, accuracy, and fairness of recommendation. Each of these metrics is customized. So, of policy evaluation, we have EPS, double robust, and direct estimator. And rank metrics, we have the NDCG, map, precision, coverage, personality. And fairness metrics, we have disparate treatment, disparate mistreatment, and disparate impact. The point is evaluate the proposed model, the proposed policy, only using user metric, but putting supply perspective too, and try, I don't know, source some kind of fairness in this context. So for our experiment, we use the Trivago dataset. In this case, the supplier is a hotel. Here's the experiment setup. So we organize the dataset into 5 tests based on several factors like interaction size, action space size, number of clicks out, and other things. It's because it is essential to compare different strategies in different contexts. So for contextual baselines, we implement different contextual based strategies. All these strategies are already implemented in the framework, so we can customize too if necessary, but here we have LeanUCB, LeanTS, eGrid, Softmax, percentile adaptive, explored and exploit, and most popular and random. And for evaluate metric, okay, we have of policy evaluation, ranking metrics, and fairness metrics. This is the cumulative mean reward. So we performed the simulation of each proposed task to the convergence of the most methods to observe the cumulative mean reward. In general, the methods start with an average read below the most popular item as they explore new recommendations and contents. Each method presents a different learn path, but the measure of them overcomes this baseline. So these methods perform various across tasks, which reinforce that there is no better exploration strategy for all scenarios. But if necessary, we can now compare different scenarios before putting a new method or new policy in production, for example. Here, in this case, we observe that linear methods like LeanTS and LeanUCB obtain better results when the search space is smaller, but does not scale well as the dimensionality of the MEDP increases, for example. Here we have rank metrics and of policy metrics. So first, we can confirm the hypothesis that the precision metrics high correlates to the simulation results. Is a good thing. But the interesting here is about CRM optimizer. So we trained 2 policies using the trained data in a supervised way, varying the loss function with and without CRM. So we observe that the policy with CRM trades off accuracy in recommendation metrics to improve the unbiased of policy metrics. This result validates that this technique is essential to reduce the effect of sampling bias during training, for example. So we evaluate the Softmax Explorer band on the REC-C series task in different perspectives of fairness. We select a few sensitive attributes for all partners, but I can choose any attributes here. We present true positive rates for true features related to the type of accommodation. So we observe that the band provides different performance per group. the hotels receive a much better recommendation for the agent than the other types, for example, such as hostel or apartment. It suggesting disparate mistreatment. On the other side, the true positive rates for cities are similar. The metrics for some cities present high confidence interval, which is directly related to have field data, but it's okay. And finally, we present the scores from the same band for 5 different hotels grouped by the user device. Many of them present the same treatment for all devices. We find that the hotel with ID 371 present a considerable low desktop device. This is a case where disparate treatment arises and the platform must address it, for example. So, to conclude, we introduced Meridian, a new open source framework to model, train, and evaluate reinforcement learning based recommended system for marketplace in a simulated environment. And we provide baseline implementations and analysis to serve as an introduction for the user. The presented results are extra contribution for our work on the task of benchmark contextual bands in recommended system, and has future release of this framework. We plan to implement extensions for multi-objective and constrained optimization to extend support for multiple stakeholders during learning, for example. The source code is available at this address. Feel free to contribute. And this is our team, and is it. Thank you very much. So